My name is Anani Majumder and I'm a senior in the School of Engineering. And this summer I worked on improving a current bone regeneration material.
My name is Stephen Bumel and I spent my summer researching the changing face of HIV/AIDS intervention in Uganda.
My name is Emily Sharp and this summer I was able to go to Peru to study osteoarthritis in ancient skeletal remains from about 1,000 years ago.
These are just a few of the many Vanderbilt undergraduates who leave the classroom to conduct the research of their choice.
This grain that I'm particularly looking at right now has a lot of different features.
For Tanya Richardson, that research involves the rare opportunity to study core samples taken from Antarctica.
It's almost alien to be able to touch something that you know has been buried deep down under the ocean and the ice in the sediment for thousands of years, and suddenly you're there touching it, the first person.
It's not unusual to find this senior working at the scanning electron microscope. On this day, she's logging and analyzing specific grains of sand, pieces of a puzzle in the mystery surrounding the climate and history of Antarctica.
I might end up seeing something. It might just be a small little groove on a grain, or it could be an X-ray photograph of my cores, and it just makes me think, what was going on? What was happening in the past to make this happen?
She's just a thoughtful person that sort of asks why and how does it work.
Tanya is working with geology professor Molly Miller.
But it's very old, desiccated, dried up moss.
Oh my God.
Miller has been to Antarctica 5 times, a continent that holds important clues to long-term climate change.
It's almost unbelievable sometimes that I'm actually working with a professor that's known throughout the geologic community and who's actually gone to Antarctica and camped there and actually touched the rocks of Antarctica. That is just, it's mind-blowing.
I think Tanya was in a class of 8, and I'd had her all semester, and I knew what kinds of questions she asked. I think that's one of the things that we do, is that we get to know our students.
Tanya's research has impacted her in more ways than even she imagined.
I've also learned a lot about myself and how I question the world and how I see the world through science and how we study the world, because science is looking at the world.
I would eventually like to become an orthopedic surgeon, so working with tissue engineering with cartilage applied directly to my field.
Ankit Choksi has been doing hands-on research in biomedical engineering labs at Vanderbilt since 2006. Today, the senior is leading the design team that hopes to build a cost-effective tissue stimulator.
We actually grow cartilage cells over a 4-week period, and it's been theorized that if these culturing cells are mechanically stimulated, that they'll grow more like cartilage in the body.
This simple device only costs around $100 and can accommodate multiple experiments at one time. Current tissue stimulators cost more than $50,000.
This has the potential to revolutionize tissue engineering.
Cost is a huge factor, man, in biomedical research.
Ankit is working with Professor Prasad Shastri.
I would like to think of myself as not the kingmaker, but the one that who is able to get people to unlock their own potential.
Ankit is not the exception in this lab. Undergraduates play major roles in Shastri's labs, where they are routinely listed as co-authors in published research papers.
And I've been lucky here in Vanderbilt to have a lot of undergraduate students who've been very productive. In fact, I have another student who's working on a project that will lead to the next generation drug-elution stents, which is the stents that deliver drugs into the blood vessels.
For Ankit, this experience is a once-in-a-lifetime opportunity.
It's extremely rewarding to know that all my hard work and time has gone into something that's going to be so beneficial. I look forward to the day that this system that I developed is one day actually used in orthopedic surgery. I'm the one performing the surgery.
Whether it's developing a potentially revolutionary biomedical device or unlocking the mysteries of Antarctica, Vanderbilt undergraduates take a journey each day.
The limping there on the body. And the osteophytes.
A journey to find their passion.
It was just an amazing experience that I really don't think I would have had at another university.
The chance to be able to go somewhere and really do this kind of research, like hands-on research in another country, this is absolutely incredible. I would never have this opportunity otherwise.
I'm really lucky. I'm very glad I made the choice of Vanderbilt because there's so many opportunities as well. There's just endless.